Hello everyone and welcome to the video. So today I'll be talking about the Refrigerator Multi-Sensor Project. The Refrigerator Multi-Sensor Project consists of four main sensors: the freezer temperature sensor, the fridge temperature sensor, the room temperature sensor, and the current sensor. So the main objective of this product is to measure these sets of data, which are the freezer temperature, the fridge temperature, the room temperature, and the current, and log them into a 32 gigabyte micro SD card. Without further ado, why don't we get into the circuit as can be seen here. So first of all, we can look at the two DS18B20 temperature sensors that are connected in parallel with the data pin connected by a 4.7 kilo ohm resistor between it and the VCC pin. And as you can see here, also the VCC pins are connected to the plus 5 volts on the Arduino, and the ground pins are connected to the ground on the Arduino. And also you can see here the TMP36 temperature sensor. It's connected differently to provide better accuracy. You can see the VCC is connected to 3.3 volts instead of the plus 5 volts on the Arduino. And as you can see here, the data pin is feeding into analog pin 1, A1, and the ground is connected to the ground on the upper side of the Arduino. And for the ACS712 current sensor, as you can see here, the ground pin is connected to the ground on Arduino, and the out is connected to the analog pin A0 or A0, as I'd like to call it, on the Arduino, and VCC is connected to plus 5 volts on the Arduino. As for the LCD display, as you can see here, the register select is connected to pin D7. The RW is connected to the ground because we're basically writing information to the LCD. The enable is connected to digital pin 8 on the Arduino. Pin D4 of the LCD is connected to digital pin 5 of the Arduino. D5 of the LCD is connected to digital pin 6 on the Arduino. D6 is connected to digital pin 9 on the Arduino. And D7 is connected to digital pin 10 on the Arduino, as can be seen here. And also, as you can see, the anode is connected to positive 5 volts and the cathode is connected to the ground. And also, let's not forget the VO, which controls the contrast of the LCD display. It's connected to the B10K potentiometer, as can be seen here, and the potentiometer is also connected to the ground and the positive 5 volts. And as for the micro SD card module, as you can see here, the ground is connected to the ground on the Arduino. The VCC is connected to positive 5 volts on the Arduino. The MISO, which is the SPI output, is connected to digital pin 12 on the Arduino. The MOSI, which is the SPI input, is connected to digital pin 11 on the Arduino. The serial clock is connected to digital pin 13 on the Arduino. And finally, the select pin is connected to digital pin 4 on the Arduino. And as for the LED, as you can see here, it's connected by a 220 ohm resistor in between in order to limit the current, and it's also connected to pin A4 on the Arduino. However, it's very important to note that pin A4 here acts as a digital pin for the LED as well as for the slide switch, as will be discussed in a little bit. Pin A4 acts as digital pin 18 on the Arduino. That's very important to note. In addition, the slide switch is also connected to pin A5 on the Arduino, and it acts as pin D19, digital pin 19 on the Arduino, as well as the slide switch is connected to the ground and connected to positive 5 volts on the Arduino. However, it's very important to note that these analog pins act as digital pins and not analog A4 and A5, but D18 and D19 respectively. And now we can move on into the testing phase of the product. And as you can see here, guys, it's not unlike any other product. It has 4 sensors connected to it at the same time, and the LCD displays their data one after the other, following the other. As you can see here, here's the ACS712 range hold current sensor and the two DS18B20 temperature sensors. One is connected to the freezer. It's plugged right into the freezer, while the other is connected into the fridge, plugged into the fridge to measure the refrigerated temperature. And as for the room temperature, the sensor is located inside the box to measure the room temperature. And again, for the ACS712 range hold current sensor, as you can see here, it is connected via an extension cord. One side connected to the power supply, while the other is connected or has the small fridge connected to it, as can be seen here. Here is the cord for the small fridge. And as you can see here, the ACS current sensor is connected through the hot wire of the extension cord. And what's also amazing about this product is that not only it shows the data and displays them on the LCD display as can be seen here, it also logs the data on a memory micro SD card, 32 gigabyte micro SD card. So you can leave it overnight and check later on or the day after for the data that has been logged onto the micro SD card, which is located in the micro SD card module as shown previously in the video or in the circuit of the product. However, it is plausible that many might be wondering about the accuracy of the sensors. So here is an image or a set of images of the readings and the accuracy of the sensors. Here is an image of the room temperature sensor reading of 22.75 degrees Celsius. And right here is a commercial thermometer or a commercial temperature sensor that reads 22.9 degrees Celsius. That is almost really close to the expected value. And as for the fridge temperature sensor or the refrigerated temperature sensor, it shows a reading of 5 degrees Celsius. And as can be seen here, I set a temperature sensor, a commercial temperature sensor or a commercial thermometer, whatever you want to call it, in the fridge, and it reads or gives a reading of 4.6 degrees Celsius. And it's also clear in the image that this is the temperature probe or the temperature sensor probe of the refrigerated temperature sensor right on the left of the image. And as for the freezer temperature sensors, unfortunately there was no commercial thermometer available. However, it is known by the Canadian government website that it is safe to store food in about -18 degrees Celsius, which is very close to the reading shown here for the freezer temperature sensor of -20.5 degrees Celsius. And finally, for the current sensor, as you can see here, it shows a reading of 0.93 amperes, which is very close to the expected current, as you can see in the following image, as shown in the manual of the small refrigerator. It shows 1 ampere, as can be seen here in this image, 1 ampere current, and the value shown is 0.93 amperes, which is very close. And for the power, it shows a voltage of 115 and a current of 1. So the expected power is as follows. As you can see here, 114.2 watts, which is very close to 115 as expected. And finally, after logging all the data, we can put the SD card, plug it into any computer device. As you can see here, here is the file with all the data. Here is all the data that has been logged in that memory SD card. As you can see here, for example, here is the freezer temperature, here is the fridge temperature, the room temperature, the current, the power and energy, and so on. So here are the values that have been logged, and we can extract them into an Excel file. As you can see here, you go to data, and you click on that, and you go into the SD card. Here you go, into that file, and then you click on next, and as you can see here, here are all the values extracted into an Excel file, as can be illustrated here. As you can see, here are the values. And finally, as you can see here, the specifications for the system with an operating voltage of 5 volts and a battery with lithium polymer 5 volts with a capacity of 6,000 mAh, milliampere hour. And as you can see here, the battery input is 5 volts and 1 ampere, and the output is 5 volts and 2.4 ampere max, with a power consumption of the system of about 761.275 milliwatts. The system uses Arduino Uno Rev 3 board with a microcontroller of Atmega 328P, and the sensors, as previously discussed, two DS18B20 temperature sensors, one TMP 36 room temperature sensor, and for the current measurement we use ACS 712 range hole 5 ampere current sensor. And the display used is 16 by 2 LCD display. The case material, as previously shown, was metal with dimensions of 10 by 6 by 3.5 inches. And to log the data, we use a micro SD card, a 32 gigabyte Gigastone micro SD card, inserted in a micro SD card module. And as you can see here, the system and its specifications have been discussed. So this was all for the video, guys. I hope you liked it. Don't forget to give me a thumbs up and subscribe for more content. Thank you very, very much, and have a great, fantastic day. Thank you very much.